I'm going to try to tackle this, find the area of each regular polygon and round to the nearest tenth. This is a pentagon, and they've given me that the radius, is 10 centimeters. Alright, so what I need to do is, I'm going to try to set it up and solve to find the area of a regular polygon, which is the apothem times the perimeter divided by 2. Alright, so I don't have, where do I start on this thing? Well, I'm going to start by putting an auxiliary line in that would represent the apothem. So if I do that, I see that that creates a small right triangle, a little bit smaller than I'd like. So I'm going to pull it out here and make it larger so that I can work with it. I'm going to just put it in the same orientation so that I can more easily handle this right here. So I'm going to try to solve that right triangle. If I can solve that right triangle, then I know that the apothem cuts that side in half, so I can double it for that side, and then I would have the apothem, and then I would have the apothem, and then I could find the perimeter, and then I would divide it by 2, and I'd be able to solve this. So it all boils down to, can I solve this right triangle? And so here's where I want you to see this. See if I can get that to show up. Yeah, that's pretty good right there. So this reference chart will help you to solve this problem. Notice we're working with a pentagon in this case, and on the row where it's talking about the pentagon, it says 5 sides. There's 540 total degrees. One angle is 108 degrees. Half of one angle is 54 degrees. The hint says you're going to have to use SOHCAHTOA, and it tells you that a central angle is 72 degrees. That's really all the information that you would need to know on this, and so that's why I'm giving you that. Remember, the central angle is one of these. It's one of these angles. So the central angle is 72, 72, and they're all 72, and then the angle is 108. Well, the reason that's important is because the radius cuts the angle in half, which makes this angle 54 degrees. Okay, and then the apothem cuts this angle in half, which makes this angle 36 degrees. You only need one of those, but I wanted to show you how that worked, how that chart would work to help you get going on these problems. And so now, remember the hint SOHCAHTOA? I need to find this value, which is that value in there. How would I do that? I'm going to use this acute angle, which would make this the adjacent. This is the adjacent. This is the hypotenuse, and this is the opposite from 36. So I need A and H. Remember, that's cosine. The cosine of 36 is equal to A, the one I don't know, over H, which is 10. Okay, and then I would pull my calculator out. I'm going to make sure that it's in degrees. So I'm going to go mode. Yep, sure enough, it's in degrees. Second mode takes me back to the calculator, and then I'm just going to cross multiply this. So it's 10 times cosine of 36. I'm going to hit enter, and that tells me that the apothem is about 8.09. Okay, so 8.09 is going to go right here. We're going to use that, and then to find the perimeter, what would I do to find the perimeter? At this point, you could use Pythagorean theorem, but I'm going to stick with the SOHCAHTOA pattern, and I'm just going to use the same 36 degree angle, and I'm going to try to find, I'm going to call that X, which is going to be right over here. And so from here, that's opposite and hypotenuse, and you guys know how to set that up. That's the sine of 36 is equal to opposite, which was X, over hypotenuse, which is 10, and it's going to work exactly the same way. So it's 10 times the sine of 36, and I'm going to hit enter, and that's going to give me it's about 5.88 is what it is. Now look, that's only half of one of those sides. So this is the best way to do this if you can. Leave it in your calculator and double it. When I double it, that gives me one full side length, And what do I need for perimeter? Because this is a pentagon, I need 5 of those. So the value in my calculator now is the perimeter, which is about 58.78 roughly. All right, so I'm gonna show you a calculator trick. I'm gonna leave that in. I'm gonna hit times, and then I'm gonna go back up with my arrow. One of my students this year taught me this, and I'm gonna highlight that and hit enter, and it'll bring it down, the whole thing. That gives me a very accurate answer. Now, so this is going to be, when I hit enter, it's going to give me the apothem times the perimeter. And remember, the last step on this is to divide by 2. So when I do that, I get 237 point, they told me to round to the nearest tenth. So when I look at the tenths place, that's a 7. I look to the right, it's a 6, since that's greater than 5. I'm going to round this to 8, so it's about 237.8. What kind of units? These are centimeters, and so the answer has to be in centimeters squared. If you look at the answer doc for today's homework and you see this problem, they had the wrong answer on there. So don't be frustrated and confused. What they did was, when they solved it, they used the 10 in place of the apothem, and they solve for the radius. And anyway, this is the correct answer, and this is how you do it. And I know that's challenging, but hopefully that'll show you how to use the resource with the chart, how to use the calculator. And I know this was long, but hang in there, you'll get it.